Okie dokie, let's have a go at 18 then. Looks pretty awful, doesn't it? We've got all this thing going on here. We've got y equals log third, x to the minus third in a bracket to the power third. Log of that thing to the power third, isn't it? We need to evaluate the derivative at x equals 8. So I put down everything we need, our table of derivatives here, the ones we need. And I've also put down the properties of logs as usual, yeah? Remember, times you add, and then divide you minus, top take bottom, and power this little chap here. If it's just a simple object of power swings down, there'd be lots of log a there. Yeah, and log of 1 is 0. So with those thoughts in mind, let's just look back to our problem then. They're only simple rules, so we can only apply them to very simple structures. See this object? As an object, we consider that as one whole simple object. The whole object is to the power third. So we can use this rule here, can't we? This nice simple rule. And that way we can get rid of that problem there. So let's do that then. So y equals the third can swing down to ground level, and it'll be a third lots of log n, a third, x to the minus third. That's a step nearer tidying it up, isn't it? Now we've got a third times this thing here. We're probably going to use some sort of other rules, so I'm probably going to be nice to put it in a bracket, wouldn't it? A third of whatever comes out, just in case there's quite a few terms that come out. Now let's have a closer look at this thing here now, which goes in here. So, log n of this 1/3 times x to the minus third. Well, really, it's a third times this object. You see it? Can you see that? That's an object, a third. And the x to the minus third is also an object in its own right. So, two objects times together. Well, we can break that down, can't we? So, we're gradually breaking the structure down. So, times you add the first plus the second. So, it'll be log of the first, which is third, plus the log of the second, which is x to the minus third. There we go. Good. We've got our bracket here, so why don't we just get rid of that little thing by just expanding the bracket then. So what do we get? We get first line, y equals a third log third. Great, because that's a constant. Lovely. And then the second line, plus a third, ln x to the minus 1/3. There we go. Now, nearly there. Let's have a look at this line. Not quite, just one tidy, that thing's going to be alright. We don't need to worry about that. This is the problem. We've got a third, lots of log of x to the minus third. It's a simple object to a power, isn't it? So we use our power rule. There it is there. So we can use that rule, and that minus third can come down to be with the third that's already there. So let's write the first term, third log third. And then we've got minus times a plus, which is a minus. A third times a third is a ninth. And we've got ln x. There we go. All tidied. So now we can at long last then do the differentiation. So here's the differentiation here. So we tidied it up, and now we can do the simple differentiation. This thing here, the first term is just a constant, as we know. Tap it into the calculator if you want to check that. That differentiates to 0. Minus 1/9, and then the log x differentiates to 1 over x. So let's tidy that up now. So divide dx equals minus 1 over 9x. There we go. Now we put the input value, which should be fairly straightforward, at x equals 8 then. Divide dx equals minus 1 over 9x, and the x we overwrite with the value 8. 9 8s are 72, so it's minus, 1 over 72. There we go. Minus 1 over 72 is the answer for 18. I'll just briefly mention it then, what we did here. We wrote down this awful looking thing. We could see in the question, we work our way into the innermost part of the problem by unwrapping the log, so to speak. So it's it's a log of a single object to a power third, isn't it? So we use our power rule. This chappy swings down to ground level here. Object to a power. There we are, there's the object. Swing that down to ground level and we get here. That's a little bit easier on the eye then. Then we can see that we got this thing here, a product, a log of a product. That product there and that product there, yeah? As entities in their own right. So put the third outside a bracket, and then whatever comes along we put in the bracket itself. Times, here's the rule we invoked. You add the first object, third, log of a third, plus the log of the second object as an entity in its own right, so to speak. So there we go there. Now we can expand the bracket, 2 lines. The first line, third log third. Second line plus third log of x to the minus third. Now we can see it's a third lots of log of x to a power. Nice simple property there. There's our object to a power. we can swing that chappy down to ground level. So the minus third came down to be with a third to make minus a ninth. Lots of log x, and this was the same. So now we've got it tidied up. We spent an age tidying it up, but that makes our life easy to differentiate now, of course. So we do the differentiation. Constant goes to 0. Minus ninth, lots of log x goes to 1 over x. Tidy it up, you get that. Input the value, you get minus 1 over 72. Okie dokie, that's 18 done then. Well done, that's great stuff.